The algorithm for going from decimal to binary may not be initially intuitive to you. It is what we call a greedy approach. We subtract the largest power of 2 that is less than or equal to our decimal number, and then apply the algorithm again to what we have remaining. When we use a power of 2, we write a 1, and when we don't, we write a 0. Let's take the number 18. Looking at the two powers of 2 closest to 18, we have 32 and 16. 32 is bigger than 18, so we can't start with 2 to the 5th. 16 is less than 18, so that's where we'll start, 2 to the 4th. We write a 1 down, and then subtract 16 from 18, leaving 2. The next power of 2 is 8, which is bigger than 2, so we'll write a 0 next to our 1. Following 8 is 4, which is also bigger than 2, so we write another 0 down. The next power of 2 is 2, which is equal to 2, and so we write a 1 next to the two zeros and subtract 2 from 2, leaving 0. Now we can't quit there because there's still a power of 2 left to check, and that's 2 to the 0, which is 1. 1 is bigger than 0, so we will write a 0 after our 1. This leaves 1, 0, 0, 1, 0 as the binary number equivalent to 18. Practice again using the decimal number 113. Pause the lesson, and then we'll work through the answer quickly. 64 is the largest power of 2 less than 113. Subtracting that gives us 49. 32 is less than 49, which now leaves us with 17. 16 is less than 17, which leaves us with 1. From here we place zeros for 8, 4, and 2, and then finish with a 1. The final binary number is 1110001. Some questions that you may be thinking about. What about negative numbers? Decimal numbers? These get more difficult, and the actual implementation is beyond this course. To address negative numbers, we use a leading bit called the sign bit, which tells us the number is negative when it is set to 1. To complicate things, you must then represent the number using a system called 2's complement, which appears to invert the digits. We'll address decimal numbers in a few lessons, but for now let's consider the problem that arises when we count higher than our system allots for, an issue called overflow.